Okay, so this is the note sheet that I gave the other day, and if I were you, I would go through all of this and make sure that you understand it, okay, for the new bar graphs, all right? So the first one's an endothermic reaction, okay? And characteristics of endothermic are that the delta H is positive, all right? And the energy goes into the system, okay? It might feel cold. And what else? Let's take a look at it when we look at the graphs, okay? All right, so when you have an endothermic reaction, you're gonna have reactants, and then you're gonna have another reactants like later, and then you're gonna have products, okay? All right, and so the first one, let's just go through, this is the reaction that we did in class, but it doesn't really matter what it is, right? Let's just say I have, this was the baking soda and vinegar one, HC2H3O2 makes NaC2H3O2 plus carbon dioxide and water, okay? All right, and if it's endothermic, then I'm always gonna add the energy term as a reactant, okay? And if it's endothermic, this is how it's going to start. 2 bars of thermal energy. That's just room temperature, you know, kind of arbitrary when we mix it. And we're going to start with 2 bars of chemical energy, okay, which is really arbitrary. You can pick anything you want, but I'm just going to probably always start with 2, okay? And my reactants are NaHCO3 and HC2H3O2. That's the vinegar, all right? And in endothermic, what's always going to happen is the energy of the products is going to be higher than that of the reactants, right? Okay, because that's what endothermic means, because it's going to go from here, right? And then the energy is going to go in, okay? And then it's going to come out like this, all right? Because the energy in here is going to be more than the energy out. That means the net is going to be positive. It's going to be a net energy in, okay? So if the products have more chemical energy than the reactants, that's what we're going to see here with 2 bars of thermal, okay, and then 2 bars of chemical here and 3 bars of chemical here, okay, because it's going to get higher, all right? Okay, so in order for the reactants to start to gain more energy in the rearrangement, it's going to have to go this way. All right? Okay, so a thermal energy bar is going to have to go this way to make this 3 because there's nowhere else to get it from. All right, so we're going to have this is going to actually lower its temperature at first, okay, as this is going to increase the chemical energy, okay? And then I'm going to get the products here, which are NaC2H8O2, H3O2, carbon dioxide, and water, all right? My products still have more energy than the reactants did, okay? But what's going to happen now is if the system has a lower temperature, right, eventually it's going to kind of come back to equilibrium at room temperature, all right? So then 2 bars of thermal energy as it comes back to room temperature. So how did it get this extra box? Right? I need to get an extra box to kind of make it back to the right temperature. So that means 1 box had to come in. Okay, that's how I get a endothermic what that's coming in. Okay, and they're almost all going to look like that. So the main things that I want to see in this are that the energy chemical here is less. When it ends, the products have a higher chemical energy than before. Okay, all right, because see, now I see this here too, and the delta H is being positive. All right, and then I can write my reactants in here. Here's where they're split, and then I write my products in here. Okay, all right, so the net is energy in if it's endothermic. All right, okay, so let's look at the next one. Let me pause this so I can make one. Let me see if I can make a new one. No. Okay, good, still there. Okay, all right, so then let's do now the exothermic. Okay, all right, so in an exothermic reaction, okay, this one is, let me get my pen back. Whoa, what am I meant to do? Okay, all right, so in an exothermic reaction, that means net, the energy is going to come out of the system, okay? And the delta H is going to be negative. All right, and this is going to feel hot to you when you touch it. All right, okay, so let's look at the one we did in class, which was nitric acid plus sodium hydroxide makes sodium nitrate plus water, okay? And if it's exothermic, the energy is always going to be like a product on this side, all right? So then this is always going to say reactants, products, okay, and then products later. All right, that's always how it's going to look if it's exo. So endo is going to be reactants, reactants, products, but if it's exo, it's going to go reactants, products, products. Okay, so I'm going to go ahead and put my reactants in this box here, and sodium hydroxide. Okay, again, arbitrarily, I'm going to start with a certain amount of thermal energy, like at room temperature, and a certain amount of chemical energy. Okay, this time I know that the products are going to end up with less energy, right? Because it's going to look like this is going to be my reactants. Okay, energy in. This is where they are split apart. Okay, and then more energy is going to come out than went in. So see how low this is going to be? More energy comes out than went in. So this is going to be a negative delta H. Okay, more energy out than energy in. Okay, that's why the net is going to be energy out. All right, so I know that this chemical energy is going to have to go down, right, because it's going to have a lower energy there. So one of these guys is going to have to hop over to here. And it's always like this in exo. This is the way it's always going. The chemical energy is going to decrease. All right, so that's going to make my thermal energy be bigger now. Okay, right, and so then this is going to be warmer. All right, and then sometime later when it's products, and H2O, all right, my chemical energy is still going to be low, and this now the system is going to be hotter, and it's going to stabilize back to room temperature like this over time. That's why it says products later. Okay, so the system originally was hotter, and it's going to stabilize and go back to room temperature. Okay, so I have 4 boxes over here and only 3 over here. All right, so if that's the case, 1 had to go away, so that means 1 box has to go out. Okay, and that's my energy out, and then that's why it feels hot to you, because the heat is coming in, like say that you're holding it in your hand. All right, so 1 is going to come out. Okay, so that's always how it's going to be for exothermic. The products are going to have a lower chemical energy, all right, which is going to increase the thermal energy at first, and then it's going to like equalize with the surroundings to go back to room temperature. Okay, and that means 1 bar of energy has to come out. All right, so make sure for the quiz, if you're watching this before the quiz, you don't have to be able to draw the stuff, but you really just need to make sure that you can describe endo and exo, okay? The next quiz will be about this other stuff.